With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Well, hello students. Now we're going to see this question. The question says that a coin has been placed at the edge of a horizontal disc rotating about its vertical axis, okay, through its axis with a uniform angular speed of 2 radians per second, okay. So it is basically moving with an angular velocity of 2 radians per second. The radius of the disc is 50 centimeters. Find the minimum coefficient of friction between the disc and the coin so that the coin does not slip. So basically we need to find the minimum coefficient of friction. So what is given in the question, I'll explain you with a small diagram. That let's suppose this is a disc, okay, and it is rotating about its axis, okay. This is basically its axis and this is the midpoint, okay. So it's rotating about its axis. Let's suppose it's rotating in this way, and there is a coin placed at the edge of it, okay. So let's draw the coin with blue so that you can get the clear idea. So this coin is placed at the absolute edge, okay. We'll take the distance from the center of the coin as r, okay. So what will be the forces acting on the coin basically? If you see from here, since it is rotating, coin will have a m omega square r, okay, which we can write as centrifugal force outwards and a friction force inwards, which will balance this centrifugal force, okay. So we need to find the coefficient of friction, okay, mu of this circular disc, so that this does not get off the plate, okay, the coin does not get off the plate. So what we need to do basically, we'll start by calculating. Basically the angular speed is given in radians per second, so basically we are going to calculate it in that only. So now we have that fc, we know that it's m omega square r, okay. Means basically centrifugal force is equal to m omega square r, or we can write it as mv square by r also. But over here, since omega is given, we use two formulas. Firstly, let me write over here. We'll use two formulas of centrifugal force. One is mv square by r and another one is m omega square r, okay. Since over here omega is given, omega is equal to basically 2 radians per second, 2 radians per second. So we are going to use this omega, okay. So now what we'll have, basically mass of coin is given, no is not given, so we'll just consider it as m, and omega square is basically 2 square into 0.5, okay. Why 0.5? Because I am taking it in meters, okay, because centimeter is no unit to be considered, okay. So we have to take it in meters, otherwise there will be a lot of problem. And if you see over here, there will be a mg force acting downwards and there will be a normal force upwards. So this mg will become equal to n, okay. So I'm writing over here mg will be equal to n, okay. So over here we have this. So we'll, after calculation, what we'll have 4. Basically we'll have 2 into 2 into 1 by 2. Basically we have 2m, okay. So basically centrifugal force will be equal to 2m, and basically frictional force is basically equal to what? Basically f, small f, basically is equal to mu into n, mu into n, okay. So what is basically mu? Mu is unknown, and n is basically what? N is basically mg, you can see over here. So mu mg, we have this situation over here. So what we are gonna do from this equation, basically we have from over here, if you see the diagram properly, we can also write f is equal to fc, okay. So we'll put f is equal to fc, okay. Let's name that equation, let's name this 1, okay. So what we're gonna do, using 1, we'll have f will be equal to fc, okay. So what we'll have, basically from 2 and 3, we are gonna put the values. So we will have 2, basically mu into m into g will be equal to 2m, okay. So in bracket will be write from 2 and 3. Got it? So now what we're gonna do, basically we are gonna solve this. So after solving this, basically mu m, we will put the value of g as 10 and we'll have mu into m. So basically let's write it in different. So we'll have 10 mu m, because we put the value of g as 10, and 2m. Okay, so now m will get cancelled with m, and what we are getting over here, we are getting a very important thing that we needed to find in this question, that we'll get mu will be equal to 0.2. So we got our coefficient of friction as 0.2. So minimum coefficient of friction will be 0.2. Got it? Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.